So I'm going to hand over to you and learn a lot about something I know absolutely nothing. And I'm sure there'll be people in the room who are just as welcome to learn your knowledge as well. So welcome. Thank you for joining us today, and over to you.
So, hello everyone. My name is Hannes. I'm a technical consultant here at Rotoblas. Rotoblas itself, just to give you a quick idea for which may not know us, we are Italy-based, northern Italy-based, supplier for general timber constructions. So from membranes, which will look now, we have also connections, different type of connections, connectors, fall protection, sound insulation, and so on. And yeah, we're gonna have a look today on one of our kindly main keys, which is waterproofing, and in hand goes also the durability. And yeah, I would say we'll just get started, and I'll present you just a short overview. What will our topics be? So first, I'll get a little into the context. What's air tightness, wind tightness, when, where to apply it. Then a little also have to do with durability, the vapor diffusion, and the condensation risks we have, especially in timber constructions. Then I'll show you a few applications, a few materials I would recommend. And then at the latest, we'll have a look also about durability and the capillary ascent of timber or in the timber, and what our recommendations are. And last topic, if we have still got the time, we'll have to look at a kind of connector we developed, which is kind of bringing it all in one connector and all in one product. So yeah, I'll say, so for the general idea of air and wind tightness, what we have to do, or what we're aiming to do, is have a wind also protect our building environment, our building itself from wind, so from dry air coming from the outside, then from vapor, from the especially from the inside, heat and sound. So we are kind of avoiding heat losses in the especially in the winter, and also the opposite side in the summer, as we have generally higher temperatures on the outside and want to keep a lower temperature in the inside. Then next thing is uncontrolled vapor migration, so any humidity going from the inside or exchanging with the outside air. And then latest thing, leakage of some kind, wherever it be, and then lack of that because of any leakage, air leakage, especially lack of confront, just because it's kind of a wind blowing inside of the building. So that would be the general idea. From an energy point, as I said, we try to avoid uncalled heat lows, humid and warm air inlet in the summer. So we have a kind of in general optimized building construction, and we can use our mechanical ventilation in the proper way, as it is now in more modern buildings. They have, even in more cases, mechanical ventilation. We can use that in a proper way. And coming in hand with that, we have energy in general and economical savings because of no heat loss, no air inlet. Then from a health point of view, I kind of also one of the most important ones is to have no mold in our building, especially with timber having that risk. And with the correct applications of the different layers, we avoid this kind of health problem. So we get an increased safety, against pathologies and building, and reduced also with that reduced everything that has to do with molds, so kind of molds, powders, pollens, and contaminations. Then from comfort, lack of from the point of comfort, as I already said in the first thing, transmission of noise, as also with wind and air generally also transmits noise. It may also be that you hear, or general noise gets transmitted via the air itself, or also the wind noise. So we have a general higher comfort in the building itself. Then from our structural stability, which in a way goes in hand with the all three topics before. We keep our integrated structure itself, because we try to avoid interstellar condensation in the structure itself where we can't see it in the first place. Structural damage, which has to do with the creating of mold in the timber of the timber. So we have all the aims to get a long-lasting, durable building. Humidity, getting rid of any humidity, and I have a higher usage of this kind of structure, this kind of building, because I protected it in the right way. So what is the general idea? How can I avoid those problems? So what we talk about is a kind of a 3-level pass. So we have the air tightness and the wind tightness, and in between of those we have all this kind of installations, all the building materials, so all the studs and so the construction itself. So from the air tightness, that's basically the inside layer, which can be done via plaster or SB boards, CLT itself with membranes, or some kind of plasterboards which have an air tightness behavior. And those layers prevent any, as the name says, air from falling the inside towards the outside. So from hot, humid air to on the outside, then lower temperature air, which also we'll see and later on has another behavior with the vapor we'll try to avoid. Then the wind tightness on the outside, which we call the outside layer of the building. Those is kind of, so the why to use it, it's the wind tightness layer, prevent any outside air from going inside the building, not just inside of the rooms, but also inside of the structure itself, which then may condensate in the worst case in our structure. You can do that by using plaster, like also on the inside, USB or CLT, or some all kind of boards, or also membranes. What's kind of our solution or our recommendation, to use a kind of specific material which is doing this tightness, air wind layer tightness for you. So as I talked before about vapor, about mold forming, it has to do with the air and its humidity it contents. So generally, you see it on the right. Hot air has capability of holds more water in it. With lower temperatures, the capability of water holding on to this water decreases. So with lower, so the overall percentage of water I can have, or the air contents, may be higher with higher air temperature and lower with lower temperatures. And what I have on the building side, I have the inside which is generally a higher temperature, or especially in the winter, I have the inside with a high temperature and the outside with lower temperature. That means in the inside with high temperature air, I have more vapor, on the outside less. What the air wants to do is get from the inside to the outside. But with that, also the air gets to a lower level of temperature, so a low temperature, and which may create humidity and condensate. Because of this low temperature, with the low temperature of the air, the overall humidity may condensate. So how to avoid that? Generally, you try to look at the buildup of your wall, of your ceiling, of whatever kind of model you have. You try to create it in a way that the temperature itself, so the decreasing temperature to the outside, goes in hand with the humidity, with the humidity performance. So in the inside, you want to have something that holds on to the humidity, or maybe even blocks the humidity, and then the outside, something that lets evaporate the humidity or the vapor. So from the cold inside, warm inside to the cold outside, you have this kind of condensation risk. Every layer has a kind of behavior, how it can stop, how it can maybe stop stop, I would say stop vapor itself. It's called it's called the vapor wave diffusion factor. It's one of the specifications for a material you have to look at if you're making this kind of assumptions. And then with that factor, you're getting even a value you can, in a sense, work with, which is just this factor multiplied by the thickness of the material. So it's kind of SD value, the thickness of equivalent layer of air. So with that, then you can look at how your elements will behave, and you can create this kind of diagrams you see on the screen. So first on the wrong installation, you have condensate in the middle, kind of in the middle where the installation sits in there. So have a mold forming probably in there. But on the other hand, on the installation placed on the outside, you have you see the two lines not touching each other, so you have a higher pressure, which you can maintain through the outside, and they don't overlap. The two lines don't overlap. And what's one thing that could happen? So first of all, you will get mold or some kind of humidity concentrated in the building, or in the material, in the structure itself. But on the later point of view, you will also look or see those molds, those problems you had in the inside, also on the surface of that surface of that wall in those cases, which then naturally creates all the problems we looked or I talked about in the first 4 slides. And also the detailing, so not just the general buildup is the important thing, but also the detailing. So if I have this kind of quite specific detail, I have to look at how the heat, the vapor transforms from the inside to the outside. So on the inside, high temperature, on the outside, lower temperatures, just to keep you in mind. Inside, much vapor, much humidity. On the outside, less because of the lower temperature. So if I do make this passage too fast, so I have not enough insulation, just because this, the air or the structure gets to this low temperature too fast, it may create, condensation, which ends up in this interstellar condensation, which you may see as we looked before, those pictures on the surface at the end, but you also may not see them, but see them or kind of know them, because also the insulation itself, the insulation factor, or the possible insulation gets decreased over time. Then at the end, you discover that you have mold in your structure, in the timber structure. So what can you do against that? So here, for example, you see a few of our products and some tests we did. So from the external behavior, some addition tests, and some water cologne tests, and also some fire tests we do with our product, just to show a few. What can I do against all those problems? So mainly what you're trying to do is use okay, the slide maybe isn't that good at here. Just over hop it and go directly to this one. So what you have, or what we try to figure out is to use membranes. You can use every kind of material, but at the end you're getting rid of all the air, of all the humidity passing through your walls with those membranes. You may also do it with another material like you saw, but you can also use it with a membrane, which is kind of a very easy way to do, also quite cost effective. So we have here, for example, a roof buildup. We have all the tiles, the roofing, thermal roofing, but then on the outside, a breathable membrane, which lets all the humidity which may create or may be in the structure evaporate to the outside. But on the inside, we have a higher SD, so a higher vapor membrane, so vapor retarder even on the inside, which blocks all the humidity going inside the structure. So you don't even may have the problem forms condensation just because of the lack of humidity inside the structure. So how to choose which membrane to use? I will go a little faster on here. We have there are lots of products to choose from. Just depends what your requirements are. If you need a specific mass per unit, which may different from the roof or a wall. So roof, you're aiming for a little heavier membrane. As for the walls, you try to keep it as low weight as possible. Then the SD value, water tightness, is also important because of where to apply, how to apply it. Then the climatic zone. We have a difference if we are in the northern Europe, northern of the continent, or on the southern zone, South Africa. We have, for example, we're trying to block the humid hot air from the outside, from the less temperature air on the inside, which we in our regions we have more or less in the summer. Then also another topic is UV exposure. You may have a facade which open cladding or some kind, or roof truss, or your roof, your facade gets left open for some kind before you then come in on the second point and finish it up. So you have to have a membrane which can hold on to this UV exposure for long period of time. Then we also have other more specific specifications like the thermal resistance. Also, a membrane itself can give an advantage in installation itself. Fire reaction is also something you have to look at, especially with larger, higher buildings. So facades, you can't use flammable products, so you have to have also memory which has a certain fire specification, fire reaction. And then also important for the whole fixation part, so what you're applying on or what you're using on your membrane, the whole topic of mechanical strength is what you see on the picture or in the render on the bottom right. So, or also in the middle. So you have tearing of the membrane, you have a nail puncture, nail tearing of the puncture of the membrane. So also that's something you have to look at in general. So then we have the main properties. Then okay, as I said, SD value something. So now we can evaluate from our vapor open, so which lets vapor through the membrane on the outside, until something which is very a vapor barrier for the inside typically. And we have all those more or less a membrane for every kind of situation you may have on your structure, on your building. Then to connect those membranes, you have to use a kind of connected to seal those membranes to each other, because you can't have, or it's hard to have one sealant, so one closed layer for the whole building. So you have to kind of seal those overlaps, those gaps between those. We generally use tapes. So what kind of tapes? Also, they're very with the membrane itself. You also have to have a tape generally, which is similar to the membrane, so with the similar specification as the membrane. So also there are lots of differences where to apply which tape, which sealant, and how to apply it, what to have a look at. So main features are the mechanic or the material of support. So out of which material I have this is made this kind of tape. So if I have it from the outside, I need to have something durable, UV stable. Then next thing is the glue itself, on which surface I want to apply it, also depending on which membrane I want to use it on. Or also, for example, has to do with, I use OSB, so a board, a kind of board, instead of a membrane, but also that I need to seal all the joints, all the connections. So I have a specific tape also for that, so which is specifically made for that. Then durability, yes, durability on the long term, but also, like I said already, UV stable, so also has to do with durability. And so that's the kind of tapes. Here you see a few different application, a few different tapes where it applied. For example, on the left you see it, sealed USB for USB board, or for example on the inside, on the bottom middle, it's a connection between CLT and the concrete floor, where you just use a tape to seal all those connections, all those possible leakage points of air where maybe pass through into the buildup. Right up kind of a window sealing, and on the right we have a tape on the outside where there may be an open cladding even. So on the outside, the very durable tape, which you necessarily won't need for the other three cases, but for the outside you need this kind of high performing, high durable, long lasting tape. So just give you a few names. So like four of the ones we saw before. So Flexiband is kind of our standard performer in the tapes. It's outdoor, indoor, very adhesive. Then they have the Sealband. It's specifically made for the inside, quite light. The liner, so the base material, is kind of made of a paper, a material. So also environmentally something we can recommend. Then the Speedyband we saw before, connecting from the CLT, so from timber to concrete. It's like the name applies, very fast to handle. So we are very, very, very fast to seal all my joints. And then the last one, the front band we saw on the roof, UV stable, UV resistance, specifically made for the outside. So another four ones. So from now specifically for the inside and outside, for example, here the plasterband in and plasterband out. They can be overplastered, which is the main feature of those, which also may be something you'll have to do or gets requested. And then on the right, a smart blend. It's developed specifically for the American market, where they call it flash and tape. It's a quite soft tape. You can put into different angles, so you kind of stretch it a little bit, and they specifically, or most cases, they use it to seal all kind of window and door openings. Then you don't necessarily have only to use tapes for this kind of connection. You could also use other products. For example, here I put up some expand band, so some self-expanding material which may seal all the gaps you may have. Or also you can use foam, so just to fill out the whole cavity you have or whole room you have. Then the last thing, or the last specific box I wanted to point out, is specifically for the roofing, so for the cladding, because you're kind of with the screws you see here, you're making little holes in all your membranes, which may cause leakage of not just air but specifically water. So you have to have a way to seal those all those leakages, which we have a few products here, for example the nail band and the Gemini, which are made as you see here for this kind of application, so between membrane and the cladding or your timber structure on the outside, and to seal those leakages between or coming because of the screws itself. So now we go to the kind of the next part, or let's say durability goes in hand with all the air and vapor tightness we've seen before, because of all that possible risk we saw. So durability is quite a big big thing to say. Okay, durability, there's many topics that go below durability. For example, you just don't only need to protect, for example, here we have got the timber, so I have this kind of protection of the timber from the outside, so there isn't any water touching directly, or generally not touching water to the timber, or I'll have the timber itself protected on the outside. But you also have to look, and it's something I would like to specifically point out, is the capillary ascent of timber structures itself. Generally, what you will have in timber is kind of foundation where you then place timber on top of it, and because of the timber, because of the components of timber and how timber works, it may be that it has this capillarity function, and then it may be that it absorbs humidity, gets more humid, and then in the long term may create mold, which is something you want to avoid in every case. So what we generally recommend is some kind of barrier in between, some kind of protection in between of the foundation, which in most cases will be done out of concrete, and the timber on top. Here we see two examples for CLT as the wall build up. So you with those this kind membranes, you're blocking every humidity going from the foundation to the timber to the wall itself. And so there are also some specific topics to talk about aeration, draining, for sure drying, and also there you need a durable material. There are also some different ways you can do this, so you necessarily don't have a direct application, so directly touching the timber, so your wall structure directly going on top of the foundation, but something in between. Maybe it's made of timber, maybe made of some other element. But generally, you're always trying to stop the humid foundation or ground going into your wall. For example, here you see some older, some typical, especially here for the region buildings, where they just lifted the whole timber construction from the ground, so they avoid any kind of moisture going inside the timber, and so they have a durable, in this way they have a durable, long-lasting timber construction, so mass timber building, which you see is those buildings might be a few hundred years old, but are still intact and working properly. So you kind of want to avoid any water leakage. And one specific product we developed specifically for this is you see on the next slide. Sorry. You're trying to separate it. So here you see a few options. So you either have a specific foundation and submaterial on that, where you block all the humidity from the foundation going into the submaterial. Like in the right, you see this kind of black line underneath the concrete looking material, which is something, a layer blocking all the humidity. Or on the left, you have just something protecting the wind, the timber itself, which avoids any passage of moist of water. But there's also some specific product we developed quite recently. It's called AluStart, and its main feature is, I get the timber away from the concrete. I have, with this AluStart, I have a structural connection of the walls with the foundation, and with this way being made out of aluminium, you're stopping any moisture going up into the wall. So it's thought as a structural connection. You see, you have the connection to the ground made with general concrete towers, concrete bolts, mechanical anchors, and you have the connection to the timber, which you see, or it's quite similar to a normal angle bracket or a normal brackets, but this kind of holds it all into one place, so one solution for kind of a few problems. So at the end you have resistances in every possible direction, so you don't necessarily need any additional angle brackets. Maybe in the extremity you will have to use some additions, but already this AluStart product will hold on to every force you may have. And at the end it may look like this, and also because it's prefabricated, so you can pre-position it on the building site quite easily. It's very fast in the building site. You're placing your walls in 1 day, 2 days without going a team on the building site before. So you just are there 2 days, depending on the building you have. But then you fix those additional connectors. Then at the end it may look like this. So you have this all your walls laid out, and now the next step in this case would be just to place the timber walls on top, and in that way you don't need any other brackets and so on. You just have this solution, which kind of has an overall solution for it. Here you see the nivelling device. So you may not have a concrete foundation which is equal in any kind of ways. So you kind of have to level out all those inconsistencies. That's done by this. You see in the middle, you see this kind of device. It's a kind of attachment, that jig we call them, to apply to all, and then you can just screw them, so regulate them in the high, and at the end it gets filled out with pouring underneath, and I have leveled wall at the end without any additional work I have to do. And that would sum up my presentation for now. And I guess we now will switch over to all the different questions you may have.
Thank you very much. Very, very thorough presentation indeed. So thank you for that. Now then, what about the questions, Abraham? Are you able to? I think I saw a few flashing up on my phone as we went through. Have you got something you can put up to get the ball rolling?
There are a few in the chat.
Oh, they're in the chat, are they? Is that where I saw it? Okay. I would ask you folks if you could use the QR code and come in, then we can actually put it up on the screen. Anonymous.
Don't forget the poll, Andrew. Don't forget the
sorry.
Poll.
Sorry. No, I beg your pardon. Yeah, no, I beg your pardon. I do beg your pardon. There's the Slido, by the way, on the screen. We'll do the poll in a moment. Yeah, there's the Slido on the screen. If you would please just ask your questions via Slido, that would be hugely helpful. Let's do the poll first, then, shall we? Let's get that up and see what response we have. So, are you involved in specifying membrane tapes and air tightness in buildings? Let's see what the audience has to say about this. So about half and half there. There's about half and half. So I'm sure 51% were hugely involved and knew what you were talking about. I wonder whether the other 49%, including myself, got lost along the way at some stage. being totally honest and open with you. Let's see the second question, if we may. So are you involved in installing membranes? We got about 2/3 not involved, only 1/3 involved. Thank you. Just giving you an idea, really, Hannes, as the audience you've had today. So out of 5, how would you rate your knowledge? Well, it looks a bit middling there, doesn't it? A bit middling there, but what's that? 77% would be 3 or above. So only about just over 20% down there, not knowing too much. There you are. There's an indication of your audience there. Let's go to the next question then, please. Do you use tapes and sealants in your everyday construction detailing, etc., etc.? 55% yes, 45% no. So again, quite even Stevens there. Do any of those results surprise you, Hannes, from what you've experienced?
I have done some presentations where they were okay. What's timber? No, I would say it's maybe there are some guys which are getting into the topic I suppose. So it's lots of topics to get into at the beginning, but we are
So we've got a
working
couple
on
of
other things.
questions now that have come in on the Q&A on Slido. Sorry, the first one I think is just a statement, really. We are from the Netherlands, so congratulations and thank you for joining us. So here come the questions. What are the thoughts about using a vapor permeable airtight layer externally?
I would differentiate about airtight and vapor permeable. So generally airtight, our kind of membrane is in its way airtight, applied correctly, so sealed properly. Regarding the vapor, you could also use a different kind of membranes on the outside, but generally how we build, so we have a humid, warmer inside than on the outside. You're trying to avoid to have the vapor or the humidity passing through the outside and in that way condensating in the wall itself, in the buildup. But there are certain buildups ways, cases where you have something permeable on the outside, vapor permeable on the outside, but in every case you have to kind of have a specific look at it, because it's hard to say just in general. Okay, and generally you can do that. The way you can say, okay, something blocking vapor on the inside, something more open on the outside, that's the general way, but also that it's only here for us, let's say in our region where we are, and not in general, generally overall.
Okay, thank
There
you.
are.
So next question. In a home dwelling, is there any benefit of improving the air tightness between floors, not on the ground floor, but say on a OSB chipboard floor?
There it may even be okay, I guess, or so from inside to inside, the vapor shouldn't be out, so all the transforming or transferring humidity shouldn't be a problem or that big of a problem on the inside. Maybe in that case you can look at it as an acoustic improvement. So maybe you have air passing from one kind of dwelling to the other, or neighbors or whatever. So maybe there with something airtight, you're getting a better acoustic performance. So you're getting rid of some noise, some sounds coming from the floors, grounds.
Okay, thank you.
Speed chipboard is.
Let's have the next question then. Are you going to bring it up individually, Abraham? If we specify your products, do you provide standard detailing with these? For example, if we need to achieve a certain air tightness, less than 3.
Less, like I said, basically airtight is every kind of membrane we have is in its way airtight. So yes, the answer would be yes. We also have details. We also have kind of software to look at the wall buildups. I'll look at the walls specifically because every way it's different. So we have the a software to have a look at it specifically, and so.
Okay, well, we've got the next question up already. What are your thoughts on internal wall junctions to external walls? Should there be continuous layer, or will a timber to timber connection suffice?
I don't think I quite understand the question. Continuous layer of, or will a timber to timber connection suffice?
I don't know who's asked the question. I wonder if the questioner could enlarge on that, and we'll come back to it. Let's put the next question up. If you ask that question, perhaps you could come back to us with an enlarged question that Hannes can refer to. So do you recommend a VCL in older solid wall constructions which are being fitted with internal wall insulation by an insulated timber frame?
Let's say those kind of, so installation on the inside, it's in more or less every case special, but yes, so to get, because you're working on your wall, so you getting your insulation higher. You're aiming for a better insulation, and with that, all the passage or the temperature from the inside to the outside gets passed on in a different way. So yes, you with the different insulation, you also have to look, or have at least have a look at the vapor passage throughout the wall itself. Yeah, this, for example, would be a way to have a specific look at the buildup, because every insulation on the inside, it depends how thick the insulation is, what is the insulation you want to achieve. So this would be a way, would be a case to have a specific look at what we also do, or provide generally.
Okay.
Yeah.
What are your thoughts on internal wall junctions to external walls? Should there be a continuous layer, or will a timber? I think we've. Can you put them up one at a time for me? Thank you. Yeah, a continuous layer of VCL on the external wall before internal panel fitted in place. Is this a follow-up to the question before? I'm not sure this is a question, is it? Or
maybe.
Yeah, it seems like a follow-up on the other question, which is not very clear.
Yeah. Is this because it's anonymous? I'm not sure. I don't know who it's from. You see, I can't link.
Maybe I just. So generally, you always aiming to have a continuous leakage-free vapor control layer. So in every way, any discontinuity of that layer may cause a problem at the end. So yes, there should, or on the outside, there makes sense to use.
Confirmation, Hannes. It was the follow-up. It was the follow-up question. Yeah. Okay. Right. Can we have them up one at a time, Abraham? It'll be less confusing. Right. Your details show the VCL on the outside of the OSB layer. Is there a reason for this? Is it not better to install the VCL with OSB outside to protect it?
So it may be OSB itself is also kind of VCL layer, so vapor control layer, because it has a certain SD value. So it has a certain behavior with vapor. It blocks a slightly bit of vapor. So placing it on the inside may be that some vapor or humidity is coming through the OSB and then gets blocked by the VCL. So it may be that there you have a condensation because of high moisture. Or in general, also the OSB may be that it's generally high moisture itself. So we tend to hold the VCL, the layer, possibly at most on the inside as possible. So that it's the first layer to block itself, the vapor, the first blocking layer on the inside, and also the same also is kind of for the outside, best as possible.
Okay, thank you, Rob. That's a good one from you. So Dennis Hillier is asking, are any of your tapes or foams fire rated?
Rated, yes. So for example, we have some A2 classified products, which are, so they essentially don't burn. We have also some specifically made sealants. They are specified fire sealants, which also have a certain fire retardant behavior. Yes, that's also a topic there's always with testing and with requirements, you're always getting to do tests, so you can provide further ratings for your product. But we have quite a few of them, or quite a lot, which have a specific rating for the fire behavior for the fire. And also there's one product which is specifically called fire foam, we call them. So it's one foam made specific for all those fire behaviors or fire requirements.
I think we've now gone through all the questions on Slido. I'm just going to the chat box, and if you have a look in the chat, I think there's one from Zoe that wasn't covered earlier. My understanding is an AVCL needs to be on the warm side of the wall externally, or with a rain screen cladding, you need a membrane that lets vapor out, but not in. It seems to stop there. That's not a full question, but can you see that one? And
Yeah.
it's from Zoe in the chat box.
So, don't even know, with rain screen cladding. So
It
there
doesn't seem
generally
to be a full question to me. It seems to have been cut off.
generally the most typical control layers, vapor control layers you have is kind of way one layer, so one membrane itself has a certain function in every way. So even or it lets vapor through it or it blocks it. What you're trying to do is have two membranes, each with a different specification. So on the inside and on the outside with a different behavior with vapor. So you don't have one product doing all, but throughout the dual structure, you have those kind of two products, or two type of sealants, two type of layers, which do your vapor control.
Zoe's actually just explained she was answering a question elsewhere on the chat. That's why it's helpful actually if we can use Slido, but there we are. Let's see if there's anything else here. Jonathan Lynch is asking about the advantages of double-sided tape over single-side.
Generally, it's the kind of application you do. So, for example, a few of our membranes already come with pre-applied double-sided tape. So you don't need any additional tape on your building site. You just have the membrane with the sticking tape on them. It's just how do you prefer it. We also have the possibility to use not just double-sided tape, but also some kind of glues you apply with a cartridge. So that's also a way to seal those. Just tapes are quite frequently used because you're also quite fast and quite flexible with them, because in any way it may be that you need tapes to seal all other joints, which you can't do with double-sided tape or another glue. So you're kind of in most cases needing a kind of tape. So you just use one tape for the whole sealing purposes.
Thank you very much. I think that probably now covers all the questions that we've had either in chat or Slido. So can I thank you for your time and your knowledge, which is very extensive, I have to say. So thank you for that.
I guess
for everyone listening, I hope you found the last hour worthwhile and valuable. I'm sure you did. Someone's asked about whether it's recorded. Yes, it is. We hold these on the Constructing Excellence Midlands website. So if you go to www.cemidlands.org, if you look at events and then drill down to webinars, we have a history of webinars that actually go right back to March 2020. So over 3 years ago, we kicked these off 3 years ago during lockdown. So successful have they been that we continue now to do them on a monthly basis. All the Constructing Excellence family of organizations together with the STA and the CIOB. So you'll now see on your screen we're promoting the next one, which is 4 weeks today, Friday the 12th, again at midday. And this is around a very, very different topic, but equally important and I suppose more strategic and general: fairness, inclusion and respect in business. We all know that equality, diversity and inclusion is now coming at us in a big way, and so it should. And construction needs to get its act together. So what we're trying to do is give you an insight in 4 weeks' time how this issue can affect your business in a positive manner. So please do put a diary note to join us 4 weeks today, Friday the 12th of May at midday. So thank you for that, Abraham. And then finally, we should have a survey, I think, a final survey, which we ask you to join in, a poll which gives us some feedback on how you see these webinars that we're performing. So have we got that on the screen, Abraham, please? Something you can put up? I haven't seen it yet, unless I'm missing. Here we go. Here's the feedback survey. So if you could take just a few seconds of your time, folks, to go to the QR code or slido.com and just fill in this feedback survey. It is interesting, both for our speakers and ourselves, in terms of providing you with a future program of events. We want to know what you as an audience want us to provide for you, and it's these answers that give us that indication. So with the time exactly 1 o'clock, I'm going to thank once again Hannes. I'm going to thank our colleagues at Leaders Meets for organising this event. I'm going to wish you all a wonderful afternoon, a great weekend, and I hope to see you all again in 4 weeks. Thanks now. Bye-bye.